Welcome, guys. This is our last class meeting of the term. I want to thank everyone who's been coming all these weeks. Even if tonight is your first night coming, we're glad to see you and glad you could be here. If you haven't already, if you could please make sure that you have in front of you something to write with and up some paper. The formula sheet for week 8, I do have that up on the computer and I'm going to be sharing, but it'll be better for you if you have it in front of you the whole time. And the Web 2.0 calculator. If you haven't already, you can just click on those blue hyperlinks, I think, on the screen, and they should launch both of those things for you. And if you guys are all set, we will go ahead and get started. I'm going to start sharing my screen. Okay, just doing a quick check before we go on. Everyone can see the screen, and you see a big warning sign on the page? Okay, excellent. So I'm going to go ahead and minimize the chat like always, but I'll bring it up every few minutes. So if you have a question, just hang on to it real quick, and I will ask for questions throughout the meeting tonight. So the first thing that I have to mention, guys, and I've already sent you, I think, a couple of announcements about this, and I'm going to send you a couple more, but it begs repeating, this is the last week of class. The class and the entire term are over on Sunday. I have to turn in grades almost immediately after the term ends, so we do not have any time for anything to be turned in late. Everything is due on Sunday, so just remember, obviously your week 8 assignments are due on Sunday, your homework from week 8, your last exam, exam 4, which covers modules 7 and 8, all this financial stuff that we've been doing the last 2 weeks, that is due on Sunday. Your other exams, you got to have until Tuesday to give you some wiggle room, but we do not have until Tuesday. The term is over on Sunday, so the exam is due on Sunday. On top of that, any makeup work you want to do from your past homework assignments, if you got a grade you weren't happy with, or you just want to try to get everything to 100% or as close as you can, if you want to make up any points for any homework assignment before week 8, that's great. It's all open to you, and you can complete any late work for the homework that you want with that 10% late penalty, but the deadline is Sunday at 11:59 p.m. So no extensions after Sunday. Okay, so last week we talked about the first part of our financial section, and we were talking a lot about interest and different ways we can compound and accumulate interest. And I hope you guys saw, as you were doing your homework last week, this section, or this 2-week section that we're doing, is all about the formulas. It's about knowing the formulas or having them available on your sheet, knowing which one to use, knowing what to plug in where, and then putting it in the calculator correctly. The concepts we're doing are probably something that's a little more real world and natural for you, right? We all know what interest is. This week we're talking about annuities and loans. So I think you guys probably already have a good sense generally of what those are. So a loan is an amount of money that you borrow from a bank or wherever, and you're going to repay that money in equal payments over some life of the loan, some number of years. Annuities are very similar. Annuity is a sequence of equal payments that you make either monthly or yearly or whatever the time period is to something like a bank or an insurance company or whatever. And in either case, as you make these payments, interest is going to be added to the total amount either in your account or that you owe. And over some period of time, we can figure out how much do I currently owe on the loan. Well, what monthly payment do I need to have so that I can pay off this loan in a certain amount of time? Well, if I'm investing in an annuity, how much money will I have after a certain number of years has passed? So it's all talking about these ideas of either borrowing money or investing in something where equal periodic payments are being made. So these are the components of the formulas that you're going to see this week. So there's FV. FV stands for future value. So if you have an annuity, which is kind of like an investment, you're paying money into some kind of an investment or an annuity every, say, month or year or whatever the period is. And as you invest that money, you're also gaining interest on whatever that is. So the future value is the value that you will have total in your annuity in the future after you've made a certain number of payments and after you've accumulated the same interest that goes along with that time period. Then there's PV, which is the present value. Hopefully that's a little self-explanatory. The present value is how much is either owed or in the account right now. So if it's a loan and you're talking about present value, it means as of right now today, how much do I owe on this loan? So maybe it's your car payment. Maybe you've been paying your car payment already for 2 years and you think, man, if I wanted to just pay this off right now, how much would I owe to the lending agency? So that's your present value. PMT stands for periodic payment. So that basically means how much are you paying to this institution every month or every year or whatever the period is. Normally we do pay on months, or that's sort of what we're all probably used to, but it doesn't have to be months. But PMT is going to stand for how much am I paying at each period to this bank or to this institution. I is the interest rate per period. Now remember, last week we learned about I. I itself sometimes can be a little tricky in the formulas. You have to remember that I, lowercase I, is the interest rate per period. But sometimes the question is going to give you an interest rate, but it's not the interest rate per period, it's the interest rate per year. So you have to remember to apply this little formula here that we learned last week to convert that annual interest rate into the periodic interest rate. You do that by taking the annual rate, which is denoted by an R, and dividing it by how many times you pay or how many times you compound in 1 year. Lastly, you have N, which is the total number of payments. Similarly, sometimes you will not be given this directly and you have to find it as like a sub-step in the larger question. We learned this last week also. Excuse me. We learned this last week also. The number of total payments you make is equal to the number of payments you make in a year. So if you pay monthly, that means you would pay 12 times a year times the number of years that you pay. So for example, if you pay monthly on something, that means 12 times per year. So the M in this equation would be 12. And say you pay that for 2 years. So those 2 years would be the T. So the total number of payments you made in 2 years is going to be 24. 12 for the first year and another 12 for the second year is 24 total. Okay? So like I just said a minute ago, this week, like last week, is all about the formulas. So like last week, on your formula sheet, this is not the whole formula sheet, I just took a snippet of it. You have 2 sections. You have the future value, which is for the annuities, and you have the present value, which is mainly for the loans. So on each of these, you have this main equation that shows up as the very first entry on the list, and then you also have these 1, 2 different equations. But just like last week, remember, all 3 of these equations are basically the same equation. They are expressing the exact same relationship between the future value, the periodic payment, I, N, and all the different variables, okay? What we've done here to make your life a little easier is we've given you 3 different presentations of the exact same formula so you can pick the best one to use for whatever your homework question is based on what you were given and what you're looking to find. Remember, just like last week, we're going to pick the formula where the item that we're trying to solve for is all by itself on one side of the equal sign. So if you're talking about an annuity and you're asked to find the periodic payment, then you're going to use this formula right here in the middle, because the payment is all by itself, isolated on one side, and the other side just has all these different components that you're going to plug in. Same thing down here. Okay? Again, Hopefully everyone was using this calculator, or you don't have to use this calculator. Maybe you have an amazing calculator of your own that you wanted to use, and that's fine. But if you don't otherwise have an outstanding calculator, please consider using this calculator this week. Did everyone, by just a show of saying yes, did you guys use this calculator last week? And was it good? It's good, right? It really gives you a great way to double check yourself before you plug in your answer, because when you work on some of these kind of like old school calculators where everything's on one line, or even the calculator on your phone or whatever, it just gets kind of gnarly when you have all these components and all these fractions and exponents, and you get sort of lost in the parentheses. So this is a great calculator to use for these purposes. Okay. So like last week, that's kind of it as far as the main information you need to know. So I think what would be more helpful for us this week, rather than me going on and on and on at unnecessary levels of detail about those components, which you probably already basically get, I think it would be more helpful to do some examples. So let's go ahead and try some examples from the homework. I'm going to jump over here to my examples. But before we start that, any questions on anything we just talked about in the slides? So I see one person typing, so we'll just go ahead and hang on until she's done. And in the meantime, if the rest of you want to just make sure you have the Web 2.0 calculator open, that would be great. I actually need to open it also. Okay. So real quick, just in case you don't have it open, I'm going to throw that link into the chat. Erica, it looks like you're typing again, so I'm going to go ahead and wait until you had trouble with the interest from last week. So if you have a question about last week, I'm more than happy to go over that. Let's wait till the end so we can go through the current week's material, and then if you want to hang out at the end, we can for sure take a look at whatever you had trouble with last week. Okay. So here's the first example for this week. So it says, find I, the rate per period, and N, the number of periods for the following annuity. Now remember, we just saw this again. Oops. We just saw this again on the slides. Remember, I is equal to R over M. Remember, R is the annual interest rate, and M is the number of periods you have in 1 year. Okay? So the I here is going to be equal to, in this question, what is R? What is the annual interest rate? Yes, it's 6% or 0.06. In this particular example, they had you enter the I as a decimal, so I'm going to go ahead and use the 0.06. And what is the M? What is the number of payments in a month? I'm sorry, why did I say that? What is the number of payments in a year? Yes, thank you, it's 12. I said month because I was thinking monthly, and then it just came out of my mouth. Okay, so using the calculator, can anyone tell me what I, the rate per period, is for this example? Yes, it's 0.005. Okay, so all you would have to do is in the calculator throw in 0.06 divided by 12 to show you real quick, even though you probably got it. So it would just be 0.06 divided by 12. That's it. Okay, so 0.005 is correct. Now, it also asks, so that was the I, right? Now it also asks us to find the N, the number of total periods. So remember, N is equal to M times T. M is the total number of times you compound or you pay in a year, and T is the total number of years. So in this question, what was M again? M is 12 because we're compounding monthly. So compounding monthly means once per month. There's 12 months in a year, so 12 times per year. And what would T be in this example? How many years? Yes, it's 9, right? So the N is going to be equal to 12 times 9, which is just 108. Okay, so the rate per period, the interest rate per period, per month in this case, is 0.005 as a decimal, or that would be 0.5 as a percent if the question asked for it that way. And the number of periods in those 9 years is going to be 108. Okay, any questions about that? That one's not so bad. Let's go to the next one. Not that the next one is bad. Okay, so here, let me draw a line here to separate, because this is actually two different questions, but using the same section of the formula sheet, so I wanted to show you both on the same page. All right, so the question on the left says use the future value formula to find the indicated value. So let's take a look. First of all, we're going to use the future value formula. It tells me right here which one to use. So if I look at my formula sheet, I'm going to be using this section right here for future value, okay? On top of that, this is what it gave me. It gave me N, it gave me I, it gave me the payment. It did not give me the future value. So the future value is what I'm looking for. Remember what we said a second ago and last week, whatever you're looking for, pick the formula where that item, that variable, is all by itself on one side of the equal sign. So of this formula sheet, here we have, here we have 1, 2, 3 formulas for the same thing. Which of those 3 should I pick for this particular example? The first one, the second one, or the third one? Yes, we're going to pick this first one, right? Because the future value, which is what we were trying to find, is isolated all by itself on one side of the equal sign. Okay, let me go ahead and write it here so we can all see it at the same time. So future value is equal to the payment times 1 plus I to the nth power minus 1 all over I. Okay? All right, so now let's start plugging in what we were given into all the appropriate places. So what was the PMT? What's the payment? Yes, the payment is 118, right? They gave it to us directly. Okay? So now I have 1 plus, what is I? Yes, 0.04 raised to the n. What is n? Yep, 31 minus 1 all over, again, I was 0.04. Okay? Everybody cool with how we plugged all those numbers in? Once we have them plugged in, all we have to do is put this in the calculator correctly. So let me jump over to the calculator. Hope everybody wrote that down. So the first thing I had was 118 times. Now what I like to do when I'm doing parentheses here, so that I don't get lost in how many parentheses do I have open and how many do I have closed, when I need to insert parentheses, I go ahead and open the parentheses and close the parentheses at the same time, and then just use the arrow key on my keyboard to go back in the middle right here. That just helps me know, okay, I've opened this, I've closed this, and I've put in the middle whatever was supposed to be in the middle. So open, close, back in the middle is my personal strategy. So now that I have those parentheses that are going to be around that bigger fraction, notice I have to put parentheses again because I have that subtraction in the numerator, right? If I don't put parentheses around that whole numerator with the subtraction in it, then my order of operations is going to get all wonked up, and when I check my formula up here later, it's not going to look right. So I need to put parentheses around the numerator also. So for my numerator, I'm going to do open, closed, back in the middle. Okay? Now I'm trying to put in that 1 plus 0.04 raised to the 31st power. Well, I have to put that 1 plus 0.04 in parentheses also. So again, open, closed, back in the middle. Now I'm going to start typing. So I have 1 plus 0.04. Now that's all I needed inside that inside bit of parentheses. So now I can go outside one of my parentheses to put the exponent. Remember, the exponent on your keyboard is the little caret, Shift 6 probably for most people. If you're doing this on the phone, or if for some reason you don't have that key, you can use this key right here, and that will put in the exponent for you. The exponent was 31, so I'm going to do 31, and then from that I have to subtract 1. Now that's my whole numerator, right? Remember, I put the whole numerator in parentheses. Since I'm done typing the numerator now, I can use my arrow on the keyboard and just go outside that parentheses where I'm at, and then do divide by 0.04. Okay? All right, so now I've input everything. Before I get my answer, let's check it and make sure that it's right. So this is the way my formula looks based on how I've put it in here with all the parentheses. So check what you wrote down and the original formula and tell me if this looks correct or not. So if you think it looks correct, just say yes or correct. If you think it's incorrect, please say so and indicate what you think is incorrect. Looks like we all are agreeing that it's correct, and it is. So it is correct. So I have the 118 times the 1 plus 0.04 raised to the 31st power minus 1 all over 0.04. Okay, so since I've checked this is correct, I can go ahead and hit equals, and I get that the future value, let me go back, so I get that the future value of this annuity or whatever is $7,000.74. Okay? Simple as that. Any questions about that one? So if you, like we've been doing, if you have a question, go ahead and type it. If you do not have a question, just go ahead and don't type. And if I don't see typing, I'll know that there's no questions and we'll move on. I do see typing, so I'll go ahead and wait. Does the plus 1 and the minus 1 cancel each other out? Not in this case, because this plus 1, if they were just all by themselves, then yes, they would. But this 1 right here is combined with this 0.04 and is in these parentheses under this exponent. So basically this 1 right here can't immediately cancel this minus 1 over here because this 31 is being applied to it. So by the order of operations, I can't do that subtraction first. The first thing I have to do is this guy right here in the parentheses. Second thing I do is the exponent. Third thing would be multiplication or division, and the very last thing I get to do is subtraction. So I'm not allowed to do this subtraction until I've done this and the exponent at a minimum. Okay? If this 31 wasn't here, so we didn't have that exponent there, and if these parentheses weren't there, then yes, the plus 1 and the minus 1 would cancel. Does it make sense? Okay, any other questions about this example? Okay, then let's go ahead and look at this second example. So this one says use the future value formula to find the indicated value. So in this case, they've given us the future value, they've given us I, they've given us the payment, and they've asked us to find N. Okay, N is what we're missing. So at the formula sheet, of those three formulas, again, they told us it was future value, so we know we're in this section. Should it be the first formula, Second formula or third formula? Yes, it's going to be the third formula in this case because n was what we're trying to find, and the third one is where n is all by itself on one side of the equal sign. Okay, so let me move the chat over here so I can see what you're saying, but still write on this one. So let's go ahead and write that down. So n, that formula from the last page, is equal to natural log. Remember, we started doing that last week. We'll talk about it again in one sec. Future value times I over the payment plus 1 all over natural log of 1 plus I. Okay? Remember what we said last week? The natural log is not something I want you to worry about too much. Just know that the natural log is a function, and what that function does for us, generally speaking, is it lets us get at variables that are in an exponent. Okay? And on the calculator, all you have to do is type the letters L and N, and next to it in parentheses, whatever is supposed to go in parentheses. Okay? Why is your I, why is my I where? Because that is part of the formula. So if you have the formula sheet, if you look at the one that is solved for n, see there's the I there? Amber, I'm not sure if I'm understanding your question. Are you asking about why this I is right here? So if you look at the formula sheet, excuse me, see this is the formula right here. So what we get is natural log of FV times I divided by the payment. So it's part of the formula that it must appear right there. Does that answer your question? Let me see if I can make it a little bigger. Okay, I tried to make it bigger. Yours has the I, then FV. You mean these are switched? It says I times FV in this numerator? I is next to it like ln. Are you using the same formula sheet? You mean the I is over here next to the fraction? Like it's FV over payment and then times I on the side of it? If so, that's the same thing. Okay, Amber, if you want to show me what you're looking at a little later, if maybe you can send me a picture or something like that. But if the I can either be multiplied up in the numerator of the fraction or it could be on the outside. That's fine. It would actually be the same thing at the end. So if you're not using, I would recommend using this formula sheet so we're all using the same thing. But if you're looking in the book or on another sheet that was posted and the I is right here, right to the right of the fraction, then it's actually the same thing. Amy, you're seeing it on the other side of the plus 1. Like this whole fraction is on the other side of the plus 1? So basically, in general, just as you guys are typing, I'll just make this comment. we have some rules where, for example, we're allowed to multiply in different directions. We're allowed to add things in different directions. So it's possible to, just as we've seen here, where we have 3 different representations of the same formula, if we wanted to, we could make even more representations of this. So if you're using a formula from another source that's not this particular formula sheet and things look slightly positioned differently, they're probably equivalent and just a slightly different expression. So if you want to, and you should get the same value as long as you're plugging everything in the right place. Yes, this one that we're looking at right here is the same one that's posted in the announcements. It's the same one that's posted in the discussion board, and it's the one that was available at that hyperlink when we started class. So this is the one that I would recommend that you use. It should have pretty much everything you need for this week all in one place. So if you have a different formula sheet, I would recommend using this one because I don't really think you need anything additional, and it seems like it's causing a little confusion. I'm not sure, James, which they're looking at. Amy and Amber, can you tell me what you're looking at that had this? Maybe it's posted on another page, like in a stock. So basically, when the courses are made live, the school dumps all these resources in, and I can't delete them or add to them. All I can do is share with you guys in the announcements and the discussion board. It's a little annoying, quite frankly, but what can you do? So maybe there's something posted on a different section that the school provided that is showing things in a slightly different way, but I would recommend that you use just this one. Okay, so it must just be a sheet that someone else created and that the school uploaded, but the formulas basically are going to be the same. So I would use this one. Let me do this. I have this uploaded to my Google Drive. So here's a link to that. See if you can just go to that, and that should have the same formula sheet that we're looking at. And then everyone should be on the same page. So Amber, if you click the Google Drive link that I put, do you get this formula sheet that we're looking at? Okay, cool. And Amy, I think you were the other one who was, well, for anyone who was not using this formula sheet, just go ahead and click this link to this Google Drive, and it should bring it up for you, so we'll all be looking at the exact same thing. Okay, so any other questions about anything we've done so far, or you guys ready to go continue the problem we were on? Okay, I don't see typing, so I'm going to go ahead and go back and keep going. Okay, so this is what we were doing. We had the formula here for n. So now all we're going to do is plug in all the appropriate numbers to the right place. It's best to just write neatly and be very systematic, because the biggest problem people have with this section is just writing messy. So when you start transferring your information from the page into the calculator, you make a mistake because your writing was messy and you misread it, or putting things in the calculator incorrectly because parentheses are mismatched. So being neat and using the Web 2.0 calculator in this section solves like at least half of the problems. Okay, so we had the natural log of the future value was 12,000, right? That was given, times the I was 0.02 divided by the payment is 400 plus 1 all over natural log of 1 plus 0.02. Okay, everybody got that down? So then if I go to the calculator, let's see, move this. We're going to start putting everything in. So first I have the natural log. So you can click again this little log button down here and then select the natural log from the extra set of buttons that pops up. Or if you're like me, you can just type L and N, and that's all you have to do. Now we're going to have a bunch of stuff in parentheses next to the LN. So I always like to do open, closed, back in the middle. The first thing inside those parentheses was going to be that fraction. So I recommend putting fractions into parentheses because it tends to make sure the order of operations is correct. Since the first thing I had in that log was a fraction, I'm going to do open, closed, back in the middle. So I had the 12,000 times 0.02 divided by 400. Now that's the end of my fraction, right? So I'm going to go outside my parentheses and then plus 1. That's it for the inside portion of that natural log. So I'm going to bounce to the outside of those parentheses and then say divide by natural log, open, close parentheses, back in the middle of 1 plus 0.02. Everybody okay with how we input that? Does it look correct up here to you? I'll give it a minute so everyone can type it in. Anybody still working on this? Okay, no problem. Guys, I will take a look at that formula sheet that you guys are talking about and see what's what there. If there's anything that is incorrect, I will for sure start a ticket for the school and ask them to replace it or get it down or whatever. This one that we're using is something I created, not something the school created. The school created one might be different. It's probably old. I'm not sure, but I definitely will investigate. All right, so everyone forget about that formula sheet that's in the Module 8 folder, and let's all use the one here. I'll give you the link one more time. Let's everyone right now use this one, even if you just bring it up on your screen for now. Let's just use this one and nothing else. If for some reason you lose it after this, remember it's in the announcements and in the discussion board, in the post that says something about resources for week 8 or some title like that. Okay. Okay, so sorry, not rushing you guys, but how are we doing? Yes, Amber, I'm going to go to that link after the class meeting because I think we're all okay, I hope, using the current formula sheet, and then that's something I will get in touch with the school about if necessary down the road after class, so I don't keep you too long. Okay, so how are we doing here? Does everyone have this entered? How about this? Does anybody not have it entered? Brittany, try double checking yourself and make sure that after you enter it, it looks like this up at the top. I think your parentheses might be off somewhere and it's giving you the wrong answer. So everybody double check that after you input it looks like this, which is matching what the formula that we wrote down looks like. In case it's helpful, I'll copy paste what the line is so you can see it if you copy paste it into your Web 2.0. In Amber, you need you need parentheses in all the places that I have here. So you need parentheses around this fraction. You need parentheses around this argument. It's called an argument of the log on the top. And you need parentheses around the argument for the log on the bottom. So basically everywhere you see it up here, you need parentheses. Okay, okay, great. All right, it sounds like everyone's kind of getting it, and if not, this is the correct way to input it, so jot it down for the future. But if we go ahead and compute this, because it is correct, we get 23.73. Remember, n is the total number of periods, so it should be a whole number. So we're going to round this to a whole number. Whoops. So in this case, n is going to be 24. So there's 24 periods that need to go by in order to get to that future value with that interest rate and making that number of payments per month. Any questions? Okay, I don't see typing, so let's go ahead to the next set. All right, so again, let me go ahead and split this so we don't confuse our two questions. So what we just did was two examples using the formulas for future value. Yes, Janet, I think they always have you put in n as a whole number. Just make sure that you look at, on every question they tell you how you're supposed to input your answer, like input a whole number, or input a simplified fraction, or a decimal to so many decimal places. So just always make sure you take those extra couple seconds and check what the format is for how they want you to enter it and enter it that way. For that particular question that I pulled, it said round up to the nearest integer as needed. So we rounded up to 24. Okay, so these two examples are using the present value formula. So everyone should be looking now at the section for present value, which is the bottom section on the formula sheet that we're now all using. So here, they gave us the present value, they gave us n, they gave us I, and they did not give us the payment, PMT. So, let's see, I'm going to move this. So I have formula number 1, formula number 2, and formula number 3 for present value. Which of those three should I use for this particular question? Yes, we're going to use the second one, right? Because the payment, which is what we were looking for, is all by itself on one side of the equal sign. So that formula, to write it down again, is payment equals present value times I over 1 minus 1 plus I to the negative n. Okay? So that's the formula. So let's go ahead and start plugging in our values. So the present value was 20,655. The I was 0.017 over 1 minus, parentheses, 1 plus, again, I was 0.017 raised to the minus 103. I ran out of room. Okay? Everybody got that down? Let's go put it in the calculator. So for this one, we're going to start with the present value. So that was 20,655 times, now I have this fraction in parentheses, so open, closed, back in the middle. The top of the fraction was just that one number, just the 0.017, so that's all I needed there, divided by, now that denominator is longer, right? I have a whole series of terms with that subtraction sign in it in the denominator. So I want to make sure that whole group of things goes into the denominator. So I'm going to put the whole denominator in parentheses so that I group that whole set into the denominator. So open, closed, back in the middle. In the denominator is 1 minus, Now I have yet another series of terms in parentheses, right? So open, close, back in the middle. And in those parentheses are 1 plus 0.017. Now outside those parentheses, I put my exponent. That's the caret. And then negative 103. Okay? So this is what it looks like when I put it in that way. Now notice, guys, say I had forgotten to put in those parentheses into the denominator. Let me take them out for a second just so you can see what would happen. Okay, so if I had forgotten to put those parentheses around the denominator, I would have gotten this. Now, can we all see how this is not correct? This guy over here, right? All of that was supposed to be down here in the denominator, not randomly out here on the right-hand side hanging out. So if you typed it in this way and you look up here at the end and you see this, you need to make sure that you notice, oh dear, that is not what it looked like when I wrote it down on my paper, and that is not what the formula on the formula sheet looks like, so something is wrong. I missed parentheses or whatever, but we got to go back and double check until it looks correct. So again, the error here is that the denominator does not have parentheses around it. So I'm going to add them back. This is where the denominator started in front of that 1, and it ended here after the 103. Okay, now I look at it again and I say, okay, now it looks correct. Now that whole guy is in the denominator, and that's what I wanted. Everybody okay with getting that down? I'm going to go ahead and paste it for you just in case. Okay, so if we've all got it in, if we hit equals, we're going to get 426.22. Okay, so this is a payment. So this is an amount of money. So the question in this case asked you to input it to 2 decimal places, just like cents for money as we actually deal with it. So this is $426.22. So that's the payment you would be making every period for this particular loan or whatever. Okay? Now let's try another one. Move this. So this one over here, I'm going to see if you guys can just read it and tell me which formula we need from the formula sheet. So it says use the formula for the present value of an ordinary annuity or the amortization formula to solve the following problem. And they gave us present value, they gave us I, they gave us the payment, and they did not give us N. So first of all, on the formula sheet, should we be in the top section for future value or the bottom section for present value? We're going to be in the bottom for present value because they said right here, use the formula for present value, and they also gave us the present value. Okay, so that's why we know we need to be in the bottom in the present value section. Okay, now of those 3 formulas, should we be using the first one, the second one, or the third one? We're going to use the third one because that's the one that N was solved for. And in this case, N was what we were not provided with, right? So on the formula sheet, we're going to use this one right here, which is in the present value section, solved for N. Okay? So let's write it down. So N is equal to minus 1 times a fraction. On the top of the fraction is natural log of 1 minus PV times I, trying to fit this here, over payment. And on the bottom is natural log of 1 plus I. Okay? Now let's start plugging everything in. So N is equal to natural log, oops, I'm sorry, forgot my minus 1. N is equal to minus 1 times this fraction, natural log of 1 minus, Now, the present value was 12,000, so 12,000 times the I was 0.025 all over the payment, which was 400. And on the bottom is natural log of 1 plus I, again, was 0.025. Okay? Everybody got that? All right. Let's go over to the calculator and put it in. So we're going to start with a -1 times. Now that whole larger fraction I'm going to put in parentheses because I always like to have my fractions in parentheses. So open, closed, back in the middle. On the top of the fraction I have a log, so ln. I always put the argument, the thing connected to my natural log, in parentheses. So open, closed, back in the middle. Inside those parentheses is 1 minus, now there's another fraction, right? So I always put my fractions in parentheses. So open, close, back in the middle. This fraction was 12,000 times 0.025 divided by 400. Okay? Now I have a couple things going on here. So first I had these parentheses, right, that were just around that fraction, that little fraction inside the log. I'm done with that now, so I can bounce outside the parentheses for that fraction. And I'm also done typing in the argument for that log on the top, right? So I can go out one more parentheses because I'm done with that log. Now I need a fraction bar and the denominator. So divided by natural log. Again, the argument for the natural log is always in parentheses, so open, closed, back in the middle. And inside that log on the bottom is 1 plus 0.025. Okay, so can anyone look at this and tell me yes or no? Does it look correct? Yes, it is correct. Everything's in the right place. Everything's on the right side of the fraction. Everything's combined in the right place with the respective logs. So yes, this is correct. Everyone okay plugging it in yourself? I'll give you the copy paste here, but I don't recommend just relying on the copy paste. Really try it yourself to make sure that you're comfortable inputting that. I know, excuse me, I know it's a lot of parentheses. You just got to get used to it. It's better to organize your parentheses to do all the algebra than to do all the algebra that would be required otherwise, where you're still going to need parentheses. Okay, so now that we know this is incorrectly, I'm going to go ahead and hit equals. And I get 56.14, I think. And again, this one we were solving for n. N is the number of payments, so it should be a whole number. And indeed, this one, Janet, was it you that asked? This one did say to input an integer, so n is equal to, in this case, 57, because it says to round up to the next integer. This is an important note. This particular question and some other ones you're going to see on the homework says very specifically to round up. So the actual value we got from the calculator here was 56.14. So if you were just rounding this to a whole number, you would look at this number, the one that's right after the decimal point, and you would say, okay, well, that's a 1. I know when I see a 1, I'm supposed to round the digit next to it down. So, oh, okay, I should leave this as 56 because that's what my regular rounding rules tell me to do. But that is not correct for this question because the directions specifically say round up to the nearest integer. So even though this is a 1 and this is not what you're used to with your regular rounding rules, you got to check those directions because it says to round up. So this 56, no matter what, needs to round up to 57. Okay? Any questions about that or either of these two examples on this page? Okay, cool. So that's basically it for the formulas, guys. There's not much else except for the word problems. So we have about 5 minutes left. You guys want to see a couple word problems? Okay, let's do a couple word problems. So here's one. Hopefully you guys can read it. So it says, recently, More Money for You offered an annuity that pays 6.3% compounded monthly. If $841 is deposited into this annuity every month, how much is in the account after 12 years? Okay, so let's see if we can dissect this with the keywords and figure out which formula we need. So the first thing it says is that this is an annuity, okay? It's an annuity. Now look at your formula sheet. If it's an annuity, should you be in the top section or in the bottom section of formulas? Yes, notice that the top section, the future value stuff, it says in parentheses next to it that that is for annuities, okay? So when you see annuity, you should automatically be thinking about being in that top section of formulas. Okay, so let's see if we can identify some of the components there. So in the future value or annuity section, we had future value, right? We had payment. These are all the variables we have. We have an I, we have an N, right? That's what's in the formula. Okay, so did they give us the future value here? They did not give us the future value. That's what they asked us to find. Notice it says how much is in the account after 12 years. That's the future value. So we don't know what this is. That's what we're asked to find in this problem. Okay, well then hopefully they gave us the payment. Did they give us the payment? What's the payment? Yes, the payment is $841, right? They said $841 is deposited into this annuity every month. Okay, so we do know the payment. How about I? Did they give us I? Good job, Janet. They did not give us I. This 6.3 that you see right here is not I. That is the R. Remember we talked in the very first problem we did today about this formula? I equals R over M. Okay? Yes, it's a little tricky, so you got to be on the lookout for it. It's very tempting to just say, oh, I see an interest rate. Okay, I'm just going to plug it in. But you got to be careful of the words, especially on these word problems. Okay? So this is the R. So we got to figure out what the I is. Again, I is R, the annual interest rate, over M, which is the number of times you pay or compound in a year. So what would be the R here and what would be the M? How about R first? So it is 6.3%, but remember we have to put it in as a decimal. So what would it be as a decimal? Yes, it's 0.063. Okay? How about M? Remember, M is the number of periods we have in a year. Yes, it's 12, okay? It's 12 because they said we're compounding monthly. So monthly means 12 times in a year. Okay? So if you throw 0.063 divided by 12 into your calculator, you should get 0.00525. Okay? So I is equal to 0.00525 in this example. So be careful of that with the I. Make sure that the interest rate you're given is actually I and not R. If it's R, you need to figure out what I is as like a substep. Okay, now we had the N. Can anyone tell me what N is? Was N given to us? Remember, N is the number of periods in the time, in the total amount of time total number of years in question. Yes, it's going to be 12 times 12. So they told us that we're going to have the annuity for 12 years. But remember, that just means it's 12 years. We're compounding monthly. So every single one of those individual years, we're going to have 12 payments. So remember, N is equal to M times T, where M is the number of payments in a year, and T is the total number of years that we're having the financial instrument for. So this is going to be equal to 12 times 12 in this case, or 144. Okay? Everybody cool with how we figured out these different components from the words? Any questions about just that part, just the interpretation? Okay, so if we look at the formula sheet, which one of those formulas from the future value section should we use here? The first one, the second one, or the third one? We're going to use the first one because the first one is the one where the FV was solved for. And remember, FV was what we were asked to find for this problem. Okay, so FV is equal to the payment times, on the top of this fraction, 1 plus I to the nth power minus 1 all over I. Okay, so that's the formula. So let's go ahead and plug everything in now. So the payment was $841 times 1 plus, remember we figured out what I was. It was 0.00525 raised to the nth power. Remember, N was 144. Sorry, I should have left more room here. Hope this is readable. Minus 1 all over I, 0.00525. Okay? So I'm going to let you guys try this in the calculator first. So go ahead and try to input this guy into the calculator and let me know what you get. And then I will do it afterwards unless we all get the correct thing. So give it a try, and whenever you're done, go ahead and post what you got for the future value. Remember, after you put in your formula in the calculator, double check the display at the top to make sure everything looks good. Okay, looks like we're all getting the same amount, which is 180,000. Now, this particular question said to round to the nearest dollar. So if we're rounding to the nearest dollar here, we would get $180,300. Okay, good. So real quick, just for anyone who was having trouble, let's go ahead and put it in. I'm going to do this a little bit quick because I know we're running out of time, but this is all being recorded, so you can go ahead and try it later. So it'd be 841 times parentheses, open, close, back in the middle, another parentheses for the numerator, open, close, back in the middle, and yet another parentheses for that sequence of terms in the parentheses on top, open, close, back in the middle, 1 plus 0.00525, outside that first set of parentheses, exponent of 144, minus 1. Now we're done with the numerator, so outside that next parentheses, divided by 0.00525. I check my formula and it looks good. Let me just copy paste it. Whoops. No. Well, I didn't mean to click on that thing with shoes. Good grief. Ugh, darn it. 841 times, sorry, 1 plus 0.0525, oops, 0.0525 raised to the 144 minus 1 over 0.00525. Copy. Okay, so that's what it would be, and then if we hit equals, you see we get that value that the rest of you are getting. So great job. Now, back to this question. What happened to my pen? There it is. So that was just the first part of this question. Let me move this over here. So the second part of the question said, how much of this is interest? So that future value that we had was, again, $180,300. So that's how much is in the account after the 12 years. But remember, some of that is the amount that you actually deposited, that you paid every month with your $841, and some of it is the interest you've been accumulating. So the second part of the question says, how much of this $180,300 is actually interest? Well, if you look again at the formula sheet, you're going to see that there's a formula for interest. Okay, it's equal to the future value minus n times the payment. So all we have to do is use that formula. So interest is equal to the future value minus n times the payment. Future value was what we just found, minus, remember, n was 144 and the payment was 841. So if we throw that in the calculator real quick, what do you get? Yeah, it is 59,196. Janet, maybe just double check what you put in. Maybe you had a typo or something like that. It should be 180,300 minus 144 times 841. Okay, so of this future value amount, almost $60,000 of that is the interest you earn. So that's a lot of money in interest. Okay, any questions about this problem? Okay, can you guys hang in there for one more? This is the last one I was going to do today. Another word problem. So this one says, Acme Annuities recently offered an annuity that pays 4.2% compounded monthly. What equal monthly deposit should be made into this annuity in order to have $62,000 in 19 years? Okay, so first thing, should we be in the top section of formulas or the bottom section of formulas from the formula sheet? Yes, we're going to be on the top. Why are we on the top? What is the key word that you see here that tips you off that you should be in that top section of formulas? Annuity, right? This is an annuity. Okay, so those future value formulas at the top are for annuities. Okay, so again, we had these portions of the annuity problems, the annuity formulas, I mean. We had future value, payment, I, and N, right? Okay, were we given the future value here? The value after some period of time? Yes, we were given that. What is the value in the future? The value that we want to achieve in the future. Yes, we want to have $62,000, right? That's what it said right here. In order to have $62,000. So that's in the future, we want to have that. Okay, good. Did they give us the payment? They did not give us the payment, right? Nowhere in this question do I see anything about a payment. Okay, so I don't know what the payment is yet. Did they give us I? Good. They did not give us I, right? They gave us this 4.2%, but again, that is R, okay? So remember, I is equal to R over M. So what would I be here? What goes on the top? We put it in as a decimal, so it's going to be 0.042. How about on the bottom? Yes, 12. So this says it's compounding monthly. So if it's monthly, that means 12 times a year. So if you put the 0.042 over 12 in your calculator, you should get 0.0035. So the I is going to be 0.0035. Okay? Did they give us N? Remember, N is the number of periods. They did not give us N, right? They gave us the number of years, but that's not N. N is the number of periods, right? What was the formula for N? Yes, it's M times T. M is the number of periods in a year, and T is the number of years. So what was M again? The number of periods in 1 year? 12. And how many years? 19, exactly. So the N is going to be 12 times 19, so that's 288. Okay? Any questions about how we found any of those components from the words in the question? I'm sorry, 228, you're right. Whoops. 228, thank you. Okay, so what we did not have here was the payment, right? So if you look at your formula sheet, which of the formulas in the future value section are we going to use? Number 1, number 2, or number 3? We want the second one, right? Because the second one is the one where the payment is solved for all by itself on the left-hand side. So payment equals future value times I over 1 plus I to the n minus 1. Okay, so let's plug everything in. So the future value was 6,200,000, sorry. The I we found was 0.0035. 1 plus I, again, I is 0.0035, raised to the n we found was 228, minus 1. There we go. Okay? So go ahead and try it in the calculator and let me know what you get. This particular question said to round to the nearest cent. So the nearest cent means 2 places after the decimal point. So when you give your answer, go ahead and give it to me in the nearest cent, 2 places after the decimal point. Okay, so I don't keep you guys too long. I'm going to go ahead and give it to you. April, you're correct. So the answer is $178.16. So that's the amount of money you would have to pay every month to have $62,000 after 19 years. Okay, real quick, let's go ahead and throw it in the calculator just so we can all have it. So we had the 62,000 times my fraction, open, close, back in the middle. On the top was just that interest rate, 0.0035, divided by, now I have that denominator, I have to put the whole denominator in parentheses, so open, close, back in the middle. Then I have that series of terms that I'm going to raise to the exponent, so parentheses again, open, close, back in the middle. 1 plus 0.0035 outside the parentheses to the exponent of 228 minus 1, okay? And I go ahead and check it up here and it looks correct. Let me go ahead and copy paste it for you. And if we hit equals, we see that we get $178.16. Okay, so guys, that's it. That is a pretty comprehensive look at your work this week and how you're going to identify which formula to use, how you're going to pick the right formula from the right section, and how you're going to put it in the calculator. And we also did a couple examples of the word problem, so how you can translate the word problem and know which formula to pick and what all the different components are. Any questions about anything we did tonight, any of the problems, or anything else about Module 8? I'm glad you're glad, Janet. So we'll make week 8 count. Be the best one yet. You have a question on the practice test. Their rounding came up with different cents by several cents. Okay, April, we will go look at that, no problem. Before we do that, any other questions about what we did tonight?